Hello everyone, let us now discuss this hard problem, count the number of ideal arrays. So what is given is n an integer and maximum value. These two are integers. So describe an ideal array. So consider ideal, that means an array is considered ideal where array of I is a value from 1 to maximum value for I is between 0 and n, right, lesser than n. Okay. Array of I is divisible by array of I minus 1 for 0 less than I less than n. Return the number of distinct ideal arrays of length n. Since the answer may be very large, return it modulo 1 in 9 plus 7. Now, we are given with n is equal to 2. That means we need an array. That means the count of arrays with the size of 2 and the maximum value. The elements in that array should not exceed 5 and it should be from 1 and 5. That's it. Now, they gave the output as 10. Let us see what are the valid arrays. Right, 1 and 1. So, let us check the next condition. Array of I is divisible by array of I minus 1. And the first condition is 1 to maximum value. 1 and 1. All these are 1 to 5, right? They are not exceeding 5. Now, array of I is divisible by array of 5 minus 1. Yes. So, this is a valid array. Ideal array. Let me name it as ideal array. So 1, 2. 2 is divisible by 1. Array of I is divisible by array of I minus 1. Yes, it is ideal array. 1, 3. 3 is divisible by 1. Yes. 4 is divisible by 1. 5 is divisible by 1. So I got only 5. Where are the next 5 arrays? Let us see. Which are starting with 2. They are 2 comma 2. 2 is divisible by 2. 2 comma 4. 4 is divisible by 2. 3 comma 3. 3 is divisible by 3. 4 comma 4. 4 is divisible by 4. 5 comma 5. 5 is divisible by 5. 5 plus 2 plus 1 plus 1 plus 1 is equal to 10. If I take n is equal to 5, maximum value is equal to 3, and these are the arrays which are ideal. Now, take this 2 is lesser than or equal to n, lesser than or equal to 1 if 4. 1 is lesser than or equal to maximum value is lesser than or equal to 1 if 4. So, we cannot generate all the valid or ideal arrays, which will take much time, and we cannot also use the recursion. But wait, imagine there is given something like n is 10 and the maximum value which is given is 20. Let me first take this two concepts. First thing is dp and the second thing is stars and bars concept in combinatorics, right? Combino Combinatorics or something like that. Okay. First, let me go with the solution firstly. Now n is 10, maximum value is 20. Okay, beautiful, right? Now this is I am storing this, right? 1 2 4. Now I took 1 2 and 4. Let us see whether can I generate a sequence or subarray with this 1 2 4. Now 1 2 and then 4. Let us see. The array is just the size of 3. Why I am taking this? I'll tell you why. 2 is divisible by 1. Yes, absolutely. 4 is divisible by 2. Yes, absolutely. Now, just take this 1, 2, 4 and I am placing it in such a way that 1, 1, 2, 2 for, I am taking this 2 for 5 times and 4 for just 3 times. So 4 for 3 times, 1 for 2 times and 5 for how many times? 5 times. Now, what is the size? N is 10. Yes. N is the size of the array is 10. Yes. I have made that expectation. Right. Now, I am removing this 4. Can I place a 1 here? Absolutely no. Why? Why? Because 1 is not divisible by 4. The 1 percentile 4 will give us a what I say, right? 1, right? So it is not uh, good, right? I can place a 2 here, then I can place a 2 here, and also can I place a 2? No. Why? Why? Because I am taking a sequence that I include 1 and then I'll include 2 and then I'll include 4. And I'll tell you the formula for this combinatorics. Don't use this combinatorics. That means many people are saying that this combinatorics and this DP are so much hard, but this is just a 10th class maths formulas. I'll tell you what is going on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the array size is 10. Okay. Now what I am doing, I am placing a 1 here. I am placing just a 1 here, and I'll place a 2, and then I place a 4, and after that I place a 4 from here to here. So this is the star. These are the stars. And what is the bar now? This is the bar. So these are the bars and this is the star. This is the whole intuition of stars and bars. So many people use this as combinatorics or something like that. Now can I place this bar over here, right? And just take this away, this force away, just take this away. Now I have took this bar to the rightmost thing like that. Now what I am doing is between this and this bar I am just placing this 2, right? Okay, I am placing this 2. Now I'll place 4 at the last, right, from the next bar. Okay, now let us see. Let me just take that again, these places again, and tell you what I am doing exactly. Now, how many places are there where I can place the bar? I can place it here, I can place it here, 2, 3, 4, 5, 6, 7, 8, 9. So I have the array size as 10 and the number of places that I can place is 10 minus 1, which is 9. So if I write it as something like n minus 1, so just I am writing n minus 1. Now how many bars I am placing? Just 2. So this array size, the the array size is 3. Let me write it to 3, and I am just placing 2 bars, 3 minus 1. So I will take this as something like L, the length, minus 1. So 9C2, 10 minus 1C, 3 minus 1, n minus 1C, L minus 1. This is the formula. If you doubt, go and take a simple example of n is something like just 3 and the maximum value is 5, and for sure I will tell you that for a value like a sequence, a valid sequence of 1 to 4, you will get all those things, n minus 1, c, l minus 1. But I need to add these things. I am taking that 1 to 4, but wait, what if I have, wait a second, I am changing the color. So what if I have a sequence like 1? So after 2, I am not placing 4 anymore. I am placing a 8. So I also need this combinatorics for this, right? I need the number of combinations for this, and even I can place 1, 3, and I think 6 is divisible by 3. Yes, absolutely, yes. Now for this also I need, and I need for 1, 3, 9, and I don't go and sit here by taking all these 1, 2, 8, 1, 3, 6, 1, 3, 9, 9. Also I have 1, 2, 4, 8, and I also have this 16. 16 percentile 8 is 0, 8 percentile 4 is 0, 2 percentile 4 percentile 2 is 0, 2 percentile 1 is 0. So I can't sit in here and take all these valid sequences. But what I need to do, I'll take this db, right? I am taking this db. Now let us see. I'll tell you what I am storing in this db. It's much important to get what I am storing in this db of length L and the value V. What it will store. This is the most important thing when you are solving a db problem like this. This will store this. I am just writing what comes into my mind. This will store the number of arrays that are ideal, or let me take it as ideal or valid. I am taking it as valid. That means array of 5 is divisible by array of 5 minus 1. Valid with length L, and the last value is V. What I am saying here, just make this as a node. If you have a book or a book with a pen, just note this. This will store the number of arrays that are ideal or valid with length L, and the last value is V. Now what I am saying here, dp of 3 and 20, what this will store? This will store the number of arrays with the size of 3, and let me just write with a random thing like just the last value is 20. I am saying this. I am saying the last value is 20. I'll tell you why I am saying the last value, why I am taking this dp of v, the last value. I'll tell you in a few seconds. Now 20. I'll go to the back. Okay. Now I got something like I'll go to the back, and 20, which is divisible, like I'll take all those values. 20 is divisible by 1. Okay for now. 20 is divisible by 2. Okay for now. 20 is divisible by 3? No. It is divisible by 4, and it is divisible by 5, and it is divisible by 10 right now. Okay. Now just take this 4. Instead of taking much values, I am just taking 4. 4. Now for this 4, I am going to the back again. For this 4, what I am checking? I am checking 1. 1 is divisible by 4. Sorry, 4 is divisible by 1. Yes. 4 is divisible by 4 is divisible by 2. Yes. So I can, for this 4, I can place 1, 2. So 1 and 4 make a valid, okay, valid array. 2 and 4 make a valid. Okay. 1, 4 and 20 will valid. Yes. 2, 4 and 20 is valid. Yes. Now let us go to 2. Yes, I'm just curious that what I'll get if I go to 2. Yes, 2. Now I'll write for 2. Is 2 divisible by 1? Yes, absolutely. Is 2 divisible by 2? Yes, absolutely. And I have forgotten to take this 4, right? 4 is also divisible by 4. So take this 4 and 4, 4 and 20 is another valid. Okay. Now for 2, I have 1 and I have 2. Now I have 1, I have 2. What I'm taking here the previous one every time. I am taking the previous one every time. If you didn't hear that, I am taking the previous one every time. That's why I am using the DP. That's why I am doing the DP, right? 1 to 20 is a valid one. 2, 2 and 20 is a valid one. Just take the 5 again. 5 with 5 I'll get F1 and 5 which are divisible by 5. 1, 5 and 20 will take a valid. 1, 5 and 5, 5 and 20 will take a valid. What I am doing here, the number of values, sorry, arrays that I can get with dp of, I am having the value of v, right? I am just taking v of length L. So here if you see for 20, what I am just taking this 20 and at the length of 3, right? So I need to add this 20. Now the last value will be 5, or it will be 4, or it will be 10, or it will be 2, or it might be 1 also. You might get confused, what if it is 1? You can place a 1, bro. at the first element. Now just take this away from here. So this is the value. What is this value? It is D. Why D? D is nothing but the elements which are divisible by something like the factors of 20. So the factors of 20 are 1, 2, 4, 5, 10. These are all the values of D. Now I have something like here some values, some random values. But what is the size? It is 2. And what is the D? D is nothing but the factors of 20. So just take this something like, okay, my intuition, I am just writing the intuition for this. Just intuition is first take dp of length and value, right? Now the value can be from 1 to 20, right? So value can be from 1 to 20, right? And I need to take only where L value is 20. So get the final answer. Get the final answer will be something like take all the values of dp of where I am getting this all those values 1 and then dp of not 1 it is 10, right? The size is 10 and the value I don't care, it might be 1. Okay, for now I am just taking dp of 10 with the size of dp of size 10 and the value, the last value is 1. You might be confused that what is the value with the last value of 1 and the size of 10, 1 1. So I'll take 1 1 1 1 1 1 like this. It is 10, the size is 10. So this is how to solve this 10 and then I'm adding 2, right? So this stores how many valid arrays I got with the size of 10 and the last value was 2. I'll do this till, wait a second. I'll do this till I'll do this addition till dp of 10 and 20. Perfect. First take L value and how can I store this dp of 10 1 dp of 10 2. Now first thing dp of L value will be dp of L minus 1. So divisor. So this is the factor D. So for value is equal to V, go to every D where D is nothing but factor, right? Go to every D and dp of L minus 1 and D should be added. But as we C++ users are taking this, I think every user should do this. dp of what I am doing is nothing but mod operator, right? Doing this mod operation. So this is how you solve this problem, and the final answer will be dp of these all things. Now I need to compute n minus 1 cl minus 1. For that I need to write a ncr function, right? So ncr function. So I need to place for every valid sequence, right? If I take this 20 and the size is 3, then I am adding ncr every time. So for this I add ncr every time. So this is how you solve this problem, and if you look at the code, I think you'll get more understanding if you look at the code, right? So let us look at the code and I'll ask you a question why I am taking that. I'll tell you in a few seconds, right? So mod I have initialized factorial is something like this. Now power mod is, I'll tell you what this function is. So compute ncr, this is the function for ncr, right? Now ideal arrays, this is the main functions. Now I is equal to 1, I is less than or equal to max value, j is equal to 2 into I, j is less than or equal to max value. This is nothing but we are pre-computing. Let me write it over here. Pre-compute compute the factors of element, right? Something like values. Okay, now I am just taking dp of 15. Why? If you know why I am taking dp of 15, just comment in the comment section that why I am taking this 15 if you know, right? Now memory set dp, and this is nothing but a dp is set with the memory. Now value is equal to 1, value is less than or equal to max value, and for value is equal to 1, and I can get with the size of 1, I can get uh, is equal to 1. That means, wait a second, I'll write. So the size is 1 and values will be 1, 2, 3 till 20, right? So with value 1, I can get an array of 1 and the size is also 1, right? 2, so this is the size is also 1, right? This is 3 and the size is also 1. So that's what I have initialized dp of 1, value is equal to 1. Now for int divisors of value, that's what I did here. dp of l value, so I'm not counting this ncr here, so I'm not adding this ncr here. I'll do that at the last. I'll tell you where I am doing it. So divisors of value, dp of l value is nothing but dp of l value plus dp of l minus 1 divisor. Go through every divisor as I said. That means a factor, not a prime factor, but a factor. Now count of arrays of length 15 comma 0. So L is equal to L is less than or equal to 14. So total is equal to total plus dp of L value percentile mod. Count of arrays of length L plus is equal to total, and factorial of 0 is equal to 1, factorial of I is equal to factorial of I minus 1 into 1 into I. So the final answer is add the final answer to combinations into count of arrays of a length L. So combinations is nothing but ncr, that's it. Now so this function powered mod is used here. So in NCR, we are using this power mod. This is related to something like an algorithm. I'll tell you where this comes from. So this is how you solve this problem. And if you like this video, do share to friends and don't forget to comment out why we are using just